Today I want to talk about how you can generate a REST application. Has anybody in here so far already generated a REST application using Swagger-Codegen? Show me your hands, please. One, okay, two. Okay, great. First of all, I want to start how you can generate based on a contract. And I also want to show you how you can extend the REST application using code first. Then freeze the contract to prevent accidental changes when the application is made for production. And then in the next step, use the REST API so you can generate client code, use it in the front-end applications or in other applications. In the next step, you can access the REST API with a browser using a UI, and view and share the HTML and the PDF files with your stakeholders, and finally, how you can customize the code generator itself. This is the toolchain for today, so I will be talking about Apache CXF3, former Crossfire, and about the Swagger feature, the Spring integration and Spring Boot integration. And I will cover the Swagger tools, so you have the Swagger editor, Swagger-Codegen, Swagger UI, and Swagger to markup. Who is using already a CXF3? Apache CXF3? Only one, okay. Jboss REST easy? No one? Okay. And Jersey implementation, one, okay. So in general, who is doing Java REST API development? Okay. What other tools are you using?
Scala.
Pardon?
Scala.
Scala, okay, thank you. Okay, today we will focus on CXF3, but there are code generators for Scala as well, and for the other frameworks. So this is the basic development cycle. I hope you can read it in the back. So first of all, we start with the contract. You can use a Swagger editor, so the business analyst can edit the contract, can add the first operations, the first models. And in the next step, we can use a Swagger-Codegen to generate the server stuff. And then we can edit the server stuff, add code, add new models, add new operations, and then use Apache Crossfire. Apache Crossfire has a feature to generate the Swagger contract on the fly. So you do changes in the code, you add new methods, new models, and they get automatically reflected in the contract. And you can reuse the generated contract. You can reuse the generated contract and copy it into the original contract, or you can replace the original contract. So you have a true life cycle for your development, and it makes adding new operations and new models quite easy. So you can do contract first and code first, mix those two. This is the complete tool chain. So at the top we have the development process, and from the contract you can use the REST API using Swagger UI. Swagger UI is the interface to the REST application you can use to explore the application, and it can be used by the testers or other developers to see what's going on in the REST application. You have the Swagger-Codegen client generator to generate client code, for example, JavaScript or Java, and we have Swagger to markup to generate PDF or HTML documentation, so we can share this with our clients or stakeholders. A few words about me. I started with Spring REST 2 years ago, and soon I picked up Swagger Spring Fox libraries, and I added the theme validation there. And in the last year, I worked with the Swagger-Codegen a lot, and I created the JavaScript client language there, and added theme validation, and I improved the Celtic Fire server and client. And I worked a bit with the Swagger to Markup project. So I contributed basically the team validation there and improved the languages. And the current project is the Celtic Fire server stub generator. This is the main topic for today. So let's start with the contract. So we have the Wadle, the XML-based contract, which has come into its years. It has been founded, has been published by the W3C in 2009. And we have the new citizen for the specification languages, Swagger, JSON or YAML based. It is currently run by the Linux Foundation. And originally it has been founded by a company named Wordnik. And it has progressed over the years. And last year, the Linux Foundation has transferred the Swagger specification to the Open API initiative. And yeah, it's constantly developed. The next version is 3. And yeah, it's pretty interesting. And it's starting to get picked up by bigger companies as well. And there are others in the field, so Blueprint or RAML, but today I want to focus on Swagger. OpenAPI Swagger is a specification, a language agnostic interface to a REST application. So it's language independent, and this is its main strength. So you can generate to the client code or server code to a huge range of languages. And basically it allows you to discover and understand the operations and models of the service. So you simply look at the contract and to see what is provided by the service, and it's more human readable than XML, for instance. The supported formats are JSON and YAML. The current contract editors are Swagger Editor, which is run by SmartBear, and Eclipse's SwagEdit, which is a fork of the Represent API Studio. And we have commercial tools as well, so this is REST Studio or the Represent API Studio. And the Swagger Editor is basically a text editor with some content assistance. So if you are more developer focused, you can edit the contract there and add new operations and parameters, but personally I'm not a big fan of it. If you want to use it or if you want to give it to your business analysts, you should take a look at the commercial version where you have a UI for this. You can conveniently add parameters or methods. And Swagger Editor is more for developers for the first setup of the contract. It is provided by SmartBear, and it's a JavaScript application, and you can edit the contract and also generate the server and client stubs directly from the UI. A few words about the Swagger-Codegen. The current version is 2.2. It's a Java program with a mustache templating in it, and it allows to generate server and client code. And currently there are 40 supported languages, a huge number and a huge range of programming languages. And last year I gave the talk about Swagger-Codegen, and there were 20 languages, so it's constantly growing. The supported server stubs we want to talk about are, first of all, for Java, JAX-OS, we have 4 flavors here: the core specification, Jersey, Celtic Fire, and Rest Easy, and also Spring MVC and Spring Boot. The Celtic Fire stub provides basically all server stubs, all clients, all generators provide the possibility to generate interfaces, implementation, and models. But with the server stub, now you can also generate a complete application. So it includes the Spring configuration files, web deployment descriptor, and for Jboss, the web deployment descriptor. and you can run it as a Spring Boot application, and it also includes Spring integration tests. This is how you invoke the Java program. So you have simple parameters. You say specify the input contract, the language, and the output directory, and configuration file. And the configuration file is a JSON file, and you can add switches there and fine-tune the generator. So now let's start with a demo. So everything starts with the contract. So let's take a look at a very simple contract. So at the top you have the information block with some basic information about the REST API, the base path where it resides. You can add tags to group the paths of the REST API. And here we have the hello path and the get verb. And we have a basic hello world application with a name. We have the indicator it is required. And we have the range of the name. And we have the response codes that are supplied by the REST API. Here we simply return a string. And I have a second method, the hello greeting. And here we return a model. And the model references are at the bottom here. So you have a simple model here with two properties. So this is the basic contract. And now this is all we have for the beginning. And now we want to produce code from this and run it. I have to fire up the code generator. The code generator is simply the Java program. We have here again all the options for the Java program. And now we're going to run it. The next step, I'm going to add the Eclipse files. And now I can import it into Eclipse. So here is our project. So let's go through the generated code. First of all, we have the interface here. So at the top we have the JSOS annotations. We are only using JSON right now. Of course, we can change this to also support XML. And we have two operations here with the parameter, and we have Swagger annotations for documentation. I will talk about them later. And we have invalidation annotations here, not null, and the size and the range. So this has been picked up from the contract. It's the one-to-one mapping. And so we can use the invalidation to check if the input parameters are correct. Here for the model, this is what the model looks like. So we have a simple Pojo, and don't be scared by the XML annotations here, they are from Gzip. And for JSON we can add a switch to remove them. So for JSON they are not necessary. Only if you want to use XML, they are necessary. So far from the basic generated interface and model. Now let's continue with the implementation. So here we have the generated implementation, and we can start coding. So let's implement this one. simply processing. Now, in the next step, we also get generated the basic configuration files for the application. We have the deployment descriptor, which simply sets up the static fire servlet, and we have the Spring configuration. We have the context XML, which is a pointer to the application context. We have the Jboss deployment descriptor, and we have the application context, and this is where all the static fire configuration is done. So this is this basic static fire configuration. We are using JSON, and here is our Hello API service, the implementation. We have the Swagger feature prepared, and here is. Pardon?
What does the Swagger feature do?
The Swagger feature allows you to generate the Swagger client automatically. I will show it later. It's important. But now we simply want to run the application. So here you have the REST server, we have the Hello API reference, and that's pretty much all of the static file configuration. And one more thing we need are the tests. So let's take a look at the tests. This is the generated test class. So you have annotations for Spring integration test with the dynamic server port. And here we have the prepared invocation. So I simply remove the comments. And let's print this out. Now we do the same for the Hello model. So now we implemented the tests, and in the next step we can run this test. So let's take a look if everything is working.
Name is still now.
Yeah, thank you. I will correct this, but the test runs through, but of course it's better. We have the value here, but the test is also okay. So these are the tests, and now we want to run the application. So I start the Spring Boot application. Invoke the service, we get the JSON response, nothing special here. If I take the second one, yeah, it's no JSON document, it's simply the string, but I have a usable application now. So this was the first step, and I can also build a WAR file. WAR file, date, and that points to the application server. Let's fire it up. So now it is running at the Jboss server. It's Jboss ERP7. So you can take it. The Spring boot configuration is only used for the tests, and so to be able to fire it up, but I can simply deploy it to a Jboss container so the Spring boot dependencies are not packaged as the WAR file. But you can change this, of course. So this was the first step. Let's continue. So we created the Hello World service, we implemented it, we started it up, and we also have the tests, and we are able to deploy. In the next step, I want to show you the additional server start features. So there's the Swagger generator, the Swagger feature. We have the Wadle generator to generate a Wadle automatically. We have bean validation support, and you can also activate automatic bean validation for Jboss or Java EE7 servers. So the bean validation is transparently done in the background. You don't have to take care of it. And there's also a compression feature, logging feature, and the integration tests I already showed to you. If you want to know all the options language of Swagger-Codegen provides, there's the config help command, and it will print out small, so it will simply print out all the configuration options you have for the language, for the language generator. So here, for example, we have a switch to generate the Spring application, use the Swagger feature, use the Wadle feature, so you can fine-tune what you need and add the right switches. Now let's run the generator again with the complete feature set. For the application context, if I regenerate, in fact only the application context gets updated. So I simply remove it and I run the generator with complete with all configuration switches turned on. So this is the complete configuration. I will show you the JSON file. So this is what the JSON file looks like. So I simply have all switches turned on to show what can be done. Generate it again. There we go. And now we have all the switches and providers of Celtic file turned on. So we have the validation interceptors, we have the compression feature, we have the Wadle generator, and we have them all used in the REST server. This one out. So the name parameter was mandatory, so I simply leave it. Okay, move it. And I get the response code 400, so the request is not valid. It's validated automatically, and invalid requests are rejected. And you also see the logging feature. So you see all the requests that are coming in and going out with the details. And you see here the server now accepts compressed content. So the compression feature is turned on, the interceptor is turned on, and now the server will decompress automatically. Generator. Let's continue. So for the further development life cycle, we now want to extend the API and add new operations and new models. And we want to use the API for front-end development and other APIs. And finally, we want to freeze the contract so we don't have any accidental changes. This is the basic life cycle. So we want to add new services, new models. We can use Swagger annotations to add documentation to the Swagger contract. And we can add bean validation annotations, and they all show up in the Swagger specification. The Swagger annotations we have for the service level is at the API. To activate the Swagger contract, we have API operation to add a description to the operation, API response to add error or response codes, and their return types. And we have annotations for the model and for the model property. The next step, we can freeze the contract, so we only generate the interfaces and the models to prevent accidental changes, and we can integrate this into a job. So Maven or Gradle, for instance. And this is what the configuration looks like. So you have a Maven configuration file, and it's pretty much the same as the Java program. Well, let's do a demo again. Now we want to add a new parameter. Let's copy this one. Again for both services. So it's really important not to forget the query parameter annotations, otherwise it won't work. Unfortunately, they are mandatory. And we can also extend the model and add a new property. So give back the input parameter. Don't take care of the toString method because I can later generate it again. So let's implement this one. Parameter. Return the name. We also have to run the tests. Oh, I'm sorry. That's it so far. Now let's test if everything is something here. Okay, that's it. So now we updated the code, and now we want to, in the next step, we want to see the updated contract. So let's start again. The entry page of Certifier, so we have a list of the services, and we have here the updated contract, and we have the new parameter we added, and we also have the first name here in the header model. So the contract is updated automatically, and the same holds true for the Wadle. But for the Wadle, you don't have the invalidation annotations. So if you want to use Wadle, you have to add them yourself. I forgot to set the first name. Yes, that's correct. In the next step, we want to freeze the contract so it doesn't get changed accidentally. I can create the contract file here.
Question. From now on, you always generate the Swagger models with the Java API and copy it back to the original file, or you discard the original file?
I'm going to the original file is in a separate project. I now take the updated, the new generated contract, and simply copy it from the generated browser side and copy it to the application. You can watch it. I will show it now. So it's only generated from the code. So the blank JSON file. And I take the contract and move it here. And now I have the updated first name parameter, and everything is updated. And I want to make sure that the generation really works, so I can enter a comment here, and this comment must go after I regenerate. And I want to generate using Maven, so I copy a snippet. Yeah. This is that. So here you have the reference to the contract which resides in the project. And if I run the build now, it will generate the API and the model classes. So everything in the Gen Java folder will be overwritten. Okay, so the comment is gone. And it's now up to date. And we have freezed the contract, so now I only can edit the contract again. And if I want to change it, I have to turn off the wait configuration option. So let's continue. In the next step, we want to use the API. So we want to generate the client code stubs, so we can use them in our application, access the API with the browser using the Swagger UI, and generate HTML and PDF documentation using Swagger markup. So Swagger-Codegen allows to generate server and client code. We already had this, and we can integrate it into build jobs. Why does it make sense to generate client code? Well, you save your time. You don't have to implement the client calls manually. You have consistency with your client code. You get code completion, and developers are able to read descriptions and documentation in the IDE directly, and to get compilation errors if the API breaks the newer version. The Swagger UI allows you to access the API with a browser. It's a dynamic JavaScript application, and you can access the generated Swagger specification, so it's always consistent with the code. So you're always looking at the same, and you can run the application. You can copy the Swagger UI into your web application manually, or you can load it as a web jar. This is what it looks like. It's a simple form. You can fill in the parameters and run it. So it makes accessing the REST API really easy, and you don't have to guess the parameters. The next tool is Swagger to Markup by Robert Winkler. So it's a single-person project, and it allows to render the API in HTML or in PDF. And it uses SDKs files for this, and you can completely customize it. So this is the basic process. So first it generates SDKs files, then you can manually add additional SDKs files or add some configuration, and then you generate HTML or PDF. Then let's continue with the demo. First of all, I take the Swagger UI, I simply copy the complete JavaScript application. Run it. Exploring the application. So we have the hello world, REST API here, and I can fill in the parameters and invoke it. You only have to take care of the base path, because the base path here is automatically generated, and I have to customize it. This is possible in the application context. For the Swagger feature, there are some parameters you can enter, and I have to update them here. Again. So now it's updated, and now I can explore again. Simply enter the parameters, invoke the API. If you return no JSON, you get this no content response. This is a small bug in the Swagger UI, but for the JSON objects, this is showed correctly. So we see the response, and we can simply try out the API. But we want to code against the API. So in the next step, I want to show you how you can generate the Java language. I have a generator for this as well. So this is the generator for the Java language. I simply say I want the Java language, and let's run it. And now I have the generated Java code here, and I'm able to run a test. Here for the test, I already prepared a test with the correct base path, and now I'm able to invoke it and run against the REST API. So this is all Java code, and you have completion for the API, of course. And there are lots of other different operations that are provided, so you can make asynchronous calls and with HTTP information, so there are more flavors of it, but also you can say simply invoke the service without any specialities. So this was it for the Java language. So far, the Wado head and Wado to Java would have done nearly the same job without the working application. But for Swagger, you can also use many other different languages, not only Java, and JavaScript, for instance. So let's generate the JavaScript implementation. And here I have a simple JavaScript file. It also supports AMD and require.js or common.js. And you can simply, we have also code completion for the operations. So I see the operations here with the updated parameters, and makes using the API a lot easier. And now let's run it. JavaScript is sometimes a bit messy. This is supposed to be working, but okay, I have tried it and it works. So let's continue with the Swagger to markup. This allows you to generate the PDF and the HTML documentation. HTML, it looks like this. So I get all the resources that are supported. You have the parameters here, and you have the second operation. The model is linked here, so I can navigate to the model, and I have the properties of the model here. And the PDF pretty much looks the same. Parameters, and you can navigate to the model. Let's continue. That was it for the client code. Now let's continue with the generator. You can also customize the generated code, and this is the most interesting aspect of it. The generator is, as I already said, implemented in Java, and you have mustache files which follow naming conventions across all languages. So you have the API.mustache file, API service implementation, the Pojo for the models, and API test, for instance, for the tests. And you can use a flag, a T flag, to provide your own templates. And you only have to customize the templates you really want to. So for example, you can add a profile to the Maven configuration file so you can deploy immediately. You can add a logger decoration in the classes you want to generate, or you can customize the unit tests. You can also customize the toolchain language itself if you want to add new files or if you want to add new configuration routines for all operations, for instance. In this case, you have to extend the language class and add it to the toolchain configuration file, and you copy the language templates you need, and that's it. So it's really simple. I'm going to show it. So the custom templates I prepared look like this. So I have a simple mustache file for the Maven configuration, and I added at the bottom a deployment profile, simple deploy. And if I generate with this flag, with the T flag, you can use these templates. And the only thing I have to do is to remove the Maven configuration file so it gets newly generated. Name it. I will generate with the template. And get the profile included here. So this is simply one-to-one generated. And if we want to add, for instance, a custom configuration file, we can also add a new language. So here I extended the Swagger-Codegen for static fire. Maybe I will also show you how the Swagger-Codegen looks itself. So how it is organized, you have the languages. And for the languages, you have, for each language, there's one generator file. And you have some basic, the CLI flags at the top, this is the basic configuration. You can add the CLI options, and you can provide the name of the language, and you can, this process ops method does the main work. And there you can also read the properties and add your own files. So if you have additional files, you can edit there. And for the customized part, it's a bit simpler. So you have the CLI options at the top. I added a new CLI option to generate the Jboss deployment descriptor. And here I read the CLI flag from the properties, and I convert it to a Boolean so I can use it in the mustache templates. And then I generate the Jboss deployment structure XML file. And I only provided this additional file here. So the mustache file is simply the text file one-to-one. And so you can customize the language and add new files. And let's run this one. So here we have the deployment descriptor. And yeah, with this deployment descriptor you can also deploy to Java with the Crossfire 3 version to a Jboss EOP 6. So that was it from the code generator part. So if you still want to use Wadle, you can also use Wadle, and the only thing you have to do is you have to invoke the Wadle to Java command and use the Grasa Gzip tools, which is an extension of the Wadle to Java command, a separate open source project, and then you can activate the Swagger feature in Celtic Fire and then use the Swagger contract. So also if you still use Wadle, you can also use the Swagger feature. So some things you might come across during development. First of all, if you generate the code and you return null and you invoke the URL in the browser, you create simply no response. So don't be scared. In this case, you just forgot to add you have not yet implemented it. And don't use checks or S annotations in the implementation class, because this will disturb static fire. Only use them in the interface, of course. And if you don't use add consumes and add produces JSON at the interface, it will automatically use XML, because static fire is originally based XML, and this is the default. And don't put jettison on the class path if you want to use JSON provider, the fast XML JSON providers, because jettison will overrule anything. So if you have jettison on the class path, so it will get crazy because it doesn't work, but so you simply have to remove it to get it work. So let's sum it up. I showed you how you can generate based on a contract, how you can extend the REST API using code first, then go back to freeze the contract again, integrate it into your build job, how you can use the application, generate client code, using it in a browser, and view and share it as HTML or PDF, and how you can, some ideas how you can customize the generator. Yeah, your contribution is wanted, so if you want to use Swagger-Codegen for your target languages, please give feedback to the Swagger-Codegen project. They run 40 languages, and it's impossible to support all these languages. So they really appreciate input and pull requests if you find bugs there or you have some new features. You can also contribute to Swagger UI or Swagger editor. Both are JavaScript applications, or to Swagger to markup. So here are the links where you can find all the different tools. And that was it for me so far. I will put the demos on my GitHub account. They are not now they are not there, but I will put them today. And that was it so far. Are there any questions regarding the generator? Yes, please.
Is there a way, if I regenerate the code for the Swagger file, that it doesn't override my code, or that it just appends it or something like that?
For the interfaces and the models, it usually makes sense that they are overwritten. So you want, if you edit the contract, or you mean as
my implementation, if I modify the tests or stuff like that.
The tests and the implementation classes are never overwritten if they exist. So only at the first run they are overwritten, and with every subsequent call they stay the same. So
for new methods I have to write the tests by myself on this.
Yes. So if you write lots of new methods, you have to rename the test and run generator again. So it doesn't merge. Yes, please.
Does Swagger support also Spring Java configuration?
Yes, of course, but currently it's not implemented. So if you would like to have this and you want to do class-buster scanning for the annotations, you can do this, but you have to add the templates yourself. And if you do this, we can also write configuration switches for this to include it in the language. So right now I did everything XML based, but of course sometimes it makes sense, or for development it's easier to use class-bus scanning. So it's possible, yes. You can customize the templates, and it's quite easy to do. So I can show it briefly. So in this case, you only have to edit the message template, so you don't have to add a new Java language. If there are existing files and you don't want to change the processing, you simply use the templates. And for instance, at the API message file, so here you have the operations. It's all simple message. And if you want to add annotations here, you simply add the annotation at the import and then regenerate, and that's it. And you have to edit the application configuration, the application context, but it's basically text editing. You only have to prepare it in Java and copy it there, run the generator again, and you see, you can test if it works.
Is it documented somewhere which names are available in those templates?
That's a good question. I'm actually not sure. I haven't worked so much. I haven't changed the processing itself. So I think I have to look it up. I also have to question myself, but haven't researched on the research yet. So, but I think it's a good question, and it would make it easier if you can, at some point, say you can want to debug output of all the variables that are available in the template. So, yes, please.
The code generator. Can you run it from command line?
The code generator, you can run it from the command line. It's a simple Java program.
Okay, so you don't need Eclipse to execute code generation?
No, of course not. So you can generate the code using, it's a simple Java program. You can invoke it as a Java program, or you can run it as a Maven task or a Gradle task.
Okay.
Okay, any other questions? Yes, please.
Do you have any experience comparing Swagger with because like a few weeks ago I was looking up what to use, and a lot of people were saying Runner is far more superior, but the tool support isn't so good. So.
Yes, exactly. I think this is the main weakness. The Swagger-Codegen is really ahead of all the other specification languages in this area. So if you want to generate code, I recommend to stick with Swagger-Codegen. So if you really need something of RML, then you can choose RML. But I think the tool support for Swagger is really the big argument. And it's used by big companies like PayPal or Microsoft. And I think it has the strongest support and the strongest community right now. Okay, yes, please.
Is there a way not to have generated code under version control?
Okay. The question was, is there a way to prevent, not to have to submit the code to a versioning system? Yes, you can do this. There's a Swagger ignore file, which is automatically generated, and you can put the path here in of the files you don't want to ignore. So we have the Swagger-Codegen ignore file, and this serves your purpose. So you can also use patterns there, and this makes it easy to ignore them. I'm sorry, you asked if you don't want to check them into Git or SVN, you simply have to add the ignore option on the versioning system. So it has nothing to do with Swagger, with the Swagger-Codegen. So you only have to say, before you check it in, simply say, I want to ignore this. And the Swagger ignore file is if you want to, if you don't want to get the files updated again, if you want to protect the files. Okay. Any other questions? Okay, that was it from my side. Thank you very much for your attention. And if you have questions,